In this session, we are discussing about load shedding and load forecasting. The western region of India manages power shortage through yearly, monthly, and daily planning. Is planning utilize expected power difference. A case study of 7,000 megawatt power shortfall in the western region. Day-ahead scheduling is used to manage the load shedding and power availability. Balancing markets handle unexpected demand change and power plant outage. Real-time smart meters can improve demand forecasting accuracy. This approach can improve the grid availability and power system performance in India.
Load shedding happens when there is not enough electricity to meet people's demand. So it can damage home appliances and business and also industries. So in South Africa, it losses around 40 billion every month. Then and also it reduces the economic growth. So then to avoid the setting, future electricity demand can be predicted by linear extrapolation, ARIMA and SNS ARIMA, then a regression, and also LSTM GRU. So then linear extrapolation is uses past electricity usage trends to guess future demand. Then ARIMA and SRIMA predicts demand by finding seasonal patterns such as higher usage in summer. So next, regression uses factors like weather and economic conditions to estimate electricity demand. So then the LSTM and GRU advanced computer models that can complex patterns and also large amounts of data. In India, SRIMA is useful if electricity demands follows seasonal patterns, while LSTM is better when demand changes due to many different factors across regions.
A university campus in South Africa studies electricity usage from 55 buildings to improve the load forecasting and the load sheets. First of all, they collected the electricity usage and data from each building. They grouped with the similar power usage and predict the future electrical demands using different forecasting method. Among all the methods, Rohit gave the best result. They help to reduce uncertainty, power cuts, and improve electricity management. The method can be used in the Indian colleges by smart metering and data to be predicted demand and manage power more effectively and efficiently.
An highlighted petroleum microgrid uses weather-based forecasting and load shedding strategy to improve produce reliability. By using weather forecasting, the system can better predict unrenewable energy generation from sources like solar and wind. Studies have shown that integrating weather forecasting can increase energy available from 85% to 100%. In India, especially in coastal areas with renewable energy, microgrids weather-based forecasting can help reduce load shedding by accurately predicting power generation and managing loads more effectively.
Load shedding is the temporary interruption of electricity supply when the demand exceeds the available power, which helps to prevent complete grid failures. Grid failures are generally caused by extreme weather conditions, transmission constraints, and equipment failures. Accurate demand forecasting reduces the need for load shedding by helping utility balance electricity supply and demand effectively. As a result, AI-based demand forecasting can predict demand surges in advance, enabling proactive load management and making load shedding as a last resort measure.
Okay. So the case study on load shedding as well as the load forecasting. So why we have to forecast the load and why we have to do the load shedding? So mainly if you see the recent days in Tamil Nadu, so there are a lot of area like in Coimbatore, Chennai and some other most of the villages, they are facing the power failures during the night time as well as daytime. And especially for agriculture, they are having only 4 to 6 hours for the agriculture service, that is 3-phase service. So it is mainly because of the poor load forecasting. If you are forecasted the load well in advance, so we can able to buy the excess power from some other state or some other power plants, etc., from the private sector or from the government sector. Okay. So here, actually, the demand is day by day increases because in every day, in a new day, the one of the industries gets growing. They are getting approval and they are doing some other extension or new power plant or new industry. They are increasing day by day. Also, during this summer, most of the family, most of the residential, they are planning to buy an AC. So, if the number of ACs gets increases, the total demand in the system gets increases. But in each day, we are unable to get the new power supply, new power plant. So that here we have to forecast with respect to short duration or with respect to medium term or with respect to long term. So we have to forecast what is the load forecasting during summer, what is the load forecasting during the winter. So like that we have to forecast and we have to allocate the unit schedule based on that. For example, during this season, if we are having the high wind season, so from that time we can get more amount of power from the wind energy. Okay, that is one thing. And if you are if you go for another summer days, we are having solar thermal power plant or solar cell. So from there we can able to generate the power. And one more thing, hydroelectric power plant. So mainly pumped storage hydroelectric power plant can be used to compensate mainly during the peak hours. Because from the morning as well as evening around 6 to 9 we are facing huge power demand across the Tamil Nadu as well as India. So during that time, with the help of pumped hydroelectric power storage, so we can be able to generate electricity that can be compensated during the peak hours. Once the peak hours is over, so again the water from the lower reservoir is again pumped back into the upper reservoir. So that again it can be used for the again next peak hours. So like that we have to allocate the resources for the peak demand hours. So that we have to forecast the load, one thing. And load shedding. So normally in load shedding, for example, if you are having the 5 villages, each village consists of 20 megawatt. So totally we are having the total demand of 100 megawatt. But the power generation is only 80 megawatt. So only we can able to deliver power only to the 4 villages. So first 2 hours, the one village gets shut down. And we are delivering power to the next 4 villages. For again next 2 hours, again the second village is getting power shut down, and we are continuously supplying to the next 4 villages. So like that we have to schedule the load, so that only we can able to maintain the transformer, bus bars, as well as generator, and all the equipments in the power system can be able to be consistently stable. We can able to get a healthy condition. Suppose if you are delivering all the 80 megawatt to all the 5 villages, they are able to use it good. But because of the lower voltage, all the equipment gets heated and the lifespan of the equipment gets decreased. So that, for example, if the lifespan is 10 years, means it will go between 5 to 7 hours. So 5 to 7 years. So the difficulty are facing the lifespan of the equipment. Also, there are a lot of faults will occur in the transformer